Hello and welcome. Thank you for joining us today. My name is Ed Lima. I'm a senior product manager with the AWS AppSync team, and this is build modern serverless applications with GraphQL and AWS AppSync. Modern serverless applications empower developers so they can optimize their time and focus their effort on what will actually bring value to their business and application. Imagine you're a developer that works with multiple data sources and different technologies, and you want to easily expose data from those different data sources to applications with a single request as easily as possible. Or you have multiple microservices and want a unified secure gateway to access specific data from different microservices, also with a single call abstracting the backend complexities for clients. Or you need to push data in real time to thousands of clients, but you're not an expert in real-time infrastructure, WebSockets, connection management, fan-out, and seamless scalability. How can you take these and many other types of applications to new heights without worrying about operations and the undifferentiated heavy lifting of infrastructure, so you can focus directly on application logic that will bring value to your business, as well as increase development velocity to do so? Here's what we're going to talk about today to answer these questions. We start by quickly leveling up on GraphQL as a technology. Then we talk about AWS AppSync and how it leverages GraphQL to provide a powerful and flexible serverless API solution. We'll go to some different use cases and how customers are powering their applications with AppSync in the real world in production at scale. We'll then revisit some exciting features we released in the past months. After that, we'll explain how AppSync relates to Amplify and how AppSync and Amplify are different services but are closely integrated. Finally, we'll talk about the prime example on how AppSync and Amplify work together to make it very easy to power applications by providing a great experience for developers with a familiar programming model, abstracting the complexities of distributed cloud systems for offline scenarios, the Amplify DataStore. So let's start with GraphQL. What is GraphQL? GraphQL, as the name describes, is a query language for APIs and a runtime to fulfill those queries. It's completely unrelated to graph databases as data is not persisted in the GraphQL layer. GraphQL has both an API component to expose and access data, as well as a compute or runtime component where developers can customize their own business logic directly at the API layer. GraphQL, as the name describes it, is a data query language for APIs. It's also a runtime to fulfill those queries. GraphQL expresses a declarative language for requesting data from your application's backend. It uses a type system that allows you to understand data requirements and get meaningful error messages, making it easier to use and prototype. You define a GraphQL API with a schema based on a schema definition language or SDL. The schema is where you define different types, such as the user type and its properties of fields, like you can see here. Using something called introspection, a client can also retrieve the schema and automatically understand how the API is documented. In this schema, you can also define specific operations. There are three types of GraphQL operations: queries to read data, mutations to modify or write data, and subscriptions. Subscriptions are linked to mutations and allow to send real-time notifications to subscribe clients whenever data is changed by a mutation. In blue, that's what we call selection sets. The selection set represents a collection of fields you define to be returning in the GraphQL operation. And that's another powerful feature of GraphQL. The client defines the selection set it needs. For instance, if I only need the ID and title, I can define my selection set with only those two fields, so my client only gets exactly what it needs. But what's the best way to use GraphQL on AWS? Well, you could run a GraphQL server, but servers are so 2014, aren't they? With AWS AppSync, you can build scalable and robust applications over GraphQL with both real-time and offline capabilities. Best of all, no servers to worry about or to manage. So AppSync is a managed serverless GraphQL service, perfect for interacting with application data. It connects to resources in your own AWS account, allowing you to make your data available in real time or offline. It can be used as a GraphQL facade to any AWS service. It also allows to perform conflict detection and resolution in the cloud instead of doing it in the client. AppSync integrates with AWS Identity Access and Management, Cognito User Pools, any OpenID Connect compliant provider, or you can use API keys, providing really powerful options to secure access to your API. It's important to understand AppSync is first and foremost an application data service with real-time and offline features implemented over GraphQL with additional capabilities such as built-in authorization and conflict resolution. It's not simply a GraphQL API proxy. You can have all sorts of applications, enterprise, mobile, web, IoT apps, accessing a GraphQL API powered by AppSync to interact with different data sources in your own AWS account. AppSync allows you to power applications with the right data from no more data sources at global scale. It simplifies application development by letting you create a flexible API to securely access, manipulate, and combine data from one or more data sources. That can be databases or other APIs. AppSync APIs can access data directly on DynamoDB NoSQL tables, Aurora serverless databases, or Elasticsearch clusters. Applications can access anything in your account using Lambda functions or even REST APIs with HTTP resolvers. You can easily have both REST and GraphQL in your backend. You can use HTTP resolvers to connect directly to other AWS services, such as step functions or Event Bridge, via the regional endpoints as well. It's also possible to use local resolvers. Think of it as a pub/sub channel where data is not persisted. To get started, you need to model and define your data in a type GraphQL schema, as we mentioned before. As the API can be defined with a simple and understandable schema, it allows you to better organize and understand your data and the data flow between different downstream components of your API. We mentioned GraphQL has a built-in compute or runtime component where developers can customize their own business logic directly at the API layer. These components are called resolvers, and they provide the logical glue between the data defined in the GraphQL schema and the data in the actual data sources. Using resolvers, you can map an operation or even a single field of a type defined in the schema with a specific data source, which allows you to retrieve data from different fields in different data sources with a single API call. So let's take a look at the specific scenario, an e-commerce system. Imagine there are different services in your application backend accessible via different technologies. User data is stored in a highly scalable NoSQL table. Orders are accessed to a REST API. The current inventory stock is checked through a Lambda function, and pricing information is in a SQL database. Usually, client applications would have to make 4 or more different calls to each one of those services exposed to different API endpoints to get the data they need, thus increasing complexity on the client side. In order to get the data that I need, I'd have to make at least, again, 4 network calls, and most likely overfetch or underfetch data, as the different data sources would send an entire payload I might not need. What if I could access all the data I need from a single endpoint with a single network call? With AppSync and GraphQL, it's exactly what it can do. An AppSync GraphQL API combines the data from all these different services into a single payload the client defines, allowing to fetch only the data required for a client defining the GraphQL selection set. For instance, a smartphone has less screen real estate than a desktop application and might need less data. The data is retrieved from multiple data sources automatically for me. And these data sources can be anything, SQL, NoSQL, HTTP, it doesn't matter. GraphQL is agnostic, so you can use the best tool and the best technology for the job in your backend. The client just sees a single constructed payload receiving user profile data from DynamoDB, order details from API Gateway, as well as seamlessly injecting specific fields with inventory availability and price data from Lambda and Aurora. All of it with a single network call and from a single API endpoint, abstracting all the backend complexity. Front-end or API consumer teams can add new features or applications without waiting for a specific backend team to implement new APIs. Since GraphQL is self-documented, introspection makes it easy for front-end developers to learn what data is available from a single unified GraphQL API endpoint. Let's talk about use cases and how customers are powering their applications using AppSync at scale in production. Some use cases have detailed diagrams. I'm not going to dive deep on each use case diagram because we have lots to cover. But at the end of the session, I'll tell you where you can find the details for the most complex use cases, if you're curious and you want to learn more about them. Starting with one of my favorite use cases, real-time. Real-time technologies enable users to receive information as it happens, providing rich, engaging, and collaborative experiences. One of the most important capabilities in AppSync is built-in support for real-time data. You can use AWS AppSync to enable scalable real-time collaboration use cases by broadcasting data from the backend to all connected clients in a one-to-many scenario, or broadcasting data between clients themselves, many-to-many scenario. For instance, you could have a Lambda function in the backend retrieving data from an external source, such as another API or service, then sending a mutation to AppSync that will update a connected data source, for instance, a DynamoDB table. You can have thousands of clients subscribe to that specific mutation on AppSync, receiving a broadcast with the updates that are written to the table at the same time. AWS AppSync takes advantage of GraphQL subscriptions to perform real-time operations by pushing data to clients that choose to listen to specific events from the backend. This means that you can easily and effortlessly make any supported data source in AppSync real-time, with connection management handled automatically between the client and the service. A backend service can easily broadcast data to connected clients, or clients can send data to other clients, depending on the use case. Real-time data, connections, scalability, fan-out, and broadcasting are all handled by AppSync, allowing you to focus on your application business use cases and requirements, instead of dealing with the complex infrastructure to manage WebSocket connections at scale. Whenever a client invokes a GraphQL subscription operation, a secure WebSocket connection is automatically established and managed by AppSync, and will remain constantly connected to your backend, allowing users to receive real-time data from any supported AppSync data source. In one of our tests with our WebSockets engine, we managed to effortlessly reach 10 million active WebSocket connections on AppSync, with plenty of room to scale to much more. One of our customers in the news and media business uses AppSync to enable global newsroom planning and collaboration. Whenever there's a piece of news developing, multiple team members across the globe can collaborate, edit, plan, write, and build a story in real time as it happens, so news readers can have all the facts as soon as possible. We have another customer who provides live location as a service. AppSync is a core part of streaming hundreds of millions of live location events between apps in real time, and allow this particular customer to accelerate time to market and increase development velocity, saving months of engineering effort. Now let's move to Internet of Things. IoT devices can generate a tremendous amount of data. Analytics in the cloud and at the edge can turn this data into information. Ultimately, this information must be delivered to users. Some use cases demand real-time access to device information as it changes. You can use AWS AppSync to access IoT device data sent to AWS IoT. You can easily build a real-time dashboard in a mobile or web application to visualize telemetry from a connected car or any other IoT device. We have a customer, a prominent automotive company in Europe, uses AppSync and GraphQL to power their in-car intelligent personal assistant. Car telemetry is ingested in the system, and an AppSync API is used to power the smart assistant capabilities and applications for an entire fleet of thousands of vehicles and car owners. What happens when applications need to deal with multiple different technologies in the back end? Do your teams need to be proficient in all of those technologies to work together? That doesn't scale well. GraphQL is agnostic to data sources technology, allowing to easily abstract them for different applications. A very powerful use case for AppSync, you can retrieve and modify data from multiple polyglot data sources, such as SQL and NoSQL, or different downstream APIs with a single call. Query and create relations between different data sources using GraphQL connections. Provide real-time and offline capabilities to web and mobile clients with AWS AppSync as a GraphQL data layer over disparate polyglot backend data. Another one of our customers leveraged GraphQL and AppSync to simplify large-scale data management using a GraphQL API to interact with data lakes. It's a fascinating use case where AppSync seamlessly interacts with multiple types of databases, APIs, and services, and abstracts the different technologies to API consumers. AppSync GraphQL APIs can become a central hub for all enterprise data, integrating different microservices and databases. AppSync can be the Rosetta Stone for all enterprise application data, where any sort of front-end or back-end applications can connect using a single endpoint and access data from any service or database in their organization, provided they have appropriate credentials with proper access controls. Now let's move to microservices. What happens when you need to expose specific data from multiple microservices? You can use AppSync as a single interface to connect and aggregate multiple microservices in your application. AWS AppSync can act as a data layer and interface to connect and communicate seamlessly with multiple microservices, even if they are running on different environments or AWS accounts. We released an AppSync microservices architecture where a single AppSync API interacts with a REST API and API gateway, another AppSync GraphQL API, or services running on Fargate containers in the VPC. AWS AppSync built-in features are used to securely access, modify, consolidate, route, and map data from different microservices as a single unified gateway, providing data to clients that just need to be aware of a single GraphQL endpoint in the cloud. The data is correlated and linked by different services to a specific user using unique JWT tokens that Cognito generates for each session. Best of all, you can try this in your own AWS account with one click. An important aspect of microservices is that different teams own different services. It's important to provide a proper way for teams to collaborate, as well as make sure they don't step on each other's toes with proper isolation. You can have multiple teams working different AWS accounts and a single AppSync API used to securely access, manipulate, and combine data from both services. For instance, an API consumer can issue a query to get data from user feeds and profiles. While the client just needs to be aware of a single endpoint, in the background, AppSync is accessing feed data from one service and profile data from another service, routing and combining it all automatically, as well as abstracting all the complexity for the API consumer that doesn't need to be aware of each different service in the backend. Teams can work in isolation in their own accounts while securely providing the data via GraphQL. With AppSync and Lambda, it's possible to create organization-wide APIs. Lambda released provision concurrency support and network improvements last year. Code starts from Lambda to access VPC resources are not an issue anymore. Front-end teams can execute with very little dependency on the back-end teams, since the back-end pretty much exposes all the data that is required. This allows front-end teams to execute faster, as they just need to be aware of the data definitions in the schema, which fully abstracts the implementation and technology requirements in the backend. We talked about real-world scenarios and use cases where customers are powering applications with a scalable, secure, and reliable GraphQL API provided by AWS AppSync. We have customers in all sorts of industries and verticals, leveraging the GraphQL advantages with improved development velocity. Media and entertainment, sports, e-commerce, healthcare, transport, education, and much more. Let's move on to a quick recap on some exciting features our team launched recently. With local mocking, you can run AppSync locally in your laptop, model your data, prototype queries, and when ready, deploy and create your AppSync API in the cloud, increasing development velocity. When AppSync was released, we could only have a single authorization mechanism per API. You could only use OpenID Connect, Cognito User Pools, IAM, or API keys in a single API. Some people had to duplicate APIs for public and private access, as it wasn't possible to mix and match different authorization providers. Now you can have a global authorization mode, and you can also add multiple additional authorization providers. The most powerful capability is to be able to assign specific providers to different types or even fields in a type. For instance, I can have a type where some fields can be accessed with an API key. However, the user must be authenticated with Cognito User Pools to have access to the email field, for instance, as you can see here. Best of all, you get partial responses, allowing the client to access only the data it has permission to access. It's great as I can define security directly from a data definition in the GraphQL schema. With a click of a button, AppSync provides built-in server-side caching capabilities for any supported data source, improving the performance of latency-sensitive and high-throughput applications and allowing developers to fetch data from a fast in-memory managed cache, delivering data at low latency. It's possible to cache the entire API data retrieved from one or more data sources. So it also offers the flexibility to selectively cache specific data fields that change less frequently. We released integration with CloudWatch Log Insights, allowing you to get very useful information about your API usage. CloudWatch Log Insights enable you to interactively search and analyze your log data in Amazon CloudWatch Logs. Best of all, there are useful sample queries that allow you to get started in no time. In this example, I can access the most frequently invoked operations and resolvers in my AppSync API. It helps me understand and identify hotspots. Earlier this year, we released integration with AWS X-Ray, enabling full end-to-end tracing support for AppSync APIs. You can enable X-Ray in your APIs to get an end-to-end view of the entire request and visibility on the performance bottlenecks in components and modules. AppSync leverages VTL or Apache Velocity templates to provide a lean and fast compute runtime layer to resolve GraphQL queries or fields. It uses VTL to translate GraphQL requests from clients into a request to your data source as well as the response. Our customers have told us that sometimes they just want to write their own resolver logic in a language they are familiar with. Other customers told us they prefer to consolidate all the business logic for GraphQL resolvers for a given type or operation in a single place, where there's no need to have any code before the request takes place or after the data is retrieved from the data source. In order to address this request, we launched direct Lambda resolvers, which make VTL templates optional and integrating AppSync with Lambda. Direct Lambda resolvers make it easier to work with Lambda and GraphQL on AWS, giving you more flexibility when developing GraphQL resolvers on AppSync with Lambda data sources. Our customers often tell us how AppSync and GraphQL enables to increase and improve development velocity, allowing to ship products and applications faster in weeks as opposed to months. However, it's also very important to have powerful development tooling to do so. And that's where Amplify comes in. Some people think Amplify is AppSync or AppSync is Amplify. We all work in the same org. As a matter of fact, if I were in the office, the Amplify team would be literally next door. We work closer together, but we're still different teams. In a nutshell, AppSync is a backend GraphQL service, and Amplify allows front-end developers to quickly configure, deploy, query, and interact with AppSync APIs in minutes. The Amplify Framework provides a set of developer tools, libraries, and UI components, as well as powerful command line interface to build and manage cloud backends, easily integrating with your iOS, Android, web, and React Native apps, as well as a web hosting console service to deploy and host web applications. Amplify is focused on front-end developers and providing the best AWS experience to them. The framework allows you to deploy and interact with cloud services based on intuitive categories. There's no need to know AWS service concepts. For instance, no need to know S3 provides storage or Cognito provides Auth. You don't need to be a cloud architect to create an app on AWS with Amplify. As far as framework components are concerned, the client libraries, CLI, and UI components are fully open source. They also manage developer services such as the Amplify console that allows to deploy and host web applications, and Device Farm, which allows to test your application on real mobile devices or a browser. These are the Amplify categories. Some categories, such as the DataStore and Predictions, were released late last year. However, there are two specific categories closely related to AppSync: DataStore and the GraphQL option in the API category. In my opinion, one of the most powerful Amplify CLI tools is the GraphQL Transform. The GraphQL Transform provides a simple-to-use abstraction that helps you quickly create backends for your web and mobile applications on AWS, all based on a GraphQL schema you define. The Transform uses directives that you can associate with types or fields in the GraphQL schema. Each directive can do different things. For instance, as you can see here, @model, for instance, creates and configures DynamoDB backends and all the business logic to interact with them from AppSync. How does it work? You just need to define a data type or multiple types with their respective fields in the GraphQL schema file. The GraphQL Transform allows me to use specific schema directives in my new data type. If I include the @model directive and push the changes, the CloudFormation stack creation is started, and the GraphQL API pre-configured with all the necessary CRUD, create, read, delete, and update logic to interact with data in a linked DynamoDB table is automatically created in minutes. However, this might not be enough, as API calls are authorized only with API keys by default. How can I improve my security posture and have a proper identity provider authenticating and authorizing my API calls? It's as easy as adding another directive, @auth, with specific rules. In this case, I just want the user that created the data to be able to access and modify it. Alternatively, I can specify groups, such as an admin group, for instance, that can have extra access. If I commit the changes and update my backend with a single command, a Cognito user pool is created and automatically configured to authenticate and authorize calls to my API. Now going one step further, I have a secure, scalable serverless API that provides me with authenticated CRUD access to my data. What if I need to add search capabilities to my backend? For those not familiar with Elasticsearch, configuring and installing a cluster can be challenging. What if I could do it just by adding one extra line to my API type definition? That's exactly what's possible with the @searchable directive. I just need to push my changes once more in an Elasticsearch cluster, as well as a DynamoDB stream and a Lambda function are all deployed and configured automatically, handling the data synchronization between DynamoDB and Elasticsearch. With a few CLI comments and a couple of schema directives based on GraphQL Transform, the AWS Amplify CLI created a very powerful, secure, highly available, flexible, resilient, and scalable backend in minutes, where users can authenticate and authorize users, can be authenticated and authorized. They can create, read, update, delete, and list data, as well as perform full text search on the same data very easily and very fast. Best of all, the whole backend is managed by AWS, and you don't have to worry about maintenance or operational tasks. The CLI also has a very handy automatic code generation capabilities for AppSync APIs. CodeGen helps you generate native code based on AppSync API for iOS and Android, as well as generation of types for Flow, JavaScript, and TypeScript. You can also generate all GraphQL statements, queries, mutations, and subscriptions, so you don't have to hand code them. There's also a GraphQL Transform directive that can be used to power your application with AI/ML, orchestrating logic to multiple AWS AI services with a single GraphQL call. Imagine I want to add an image recognition to my application, then identify any text in the image, translate it to a specific language, and finally speak the text in my app. With Predictions, I just need to add these AI-related actions, and they are executed in sequence, as defined in the schema. I can have an AI-enabled API deployed in minutes and easily interact with it with few lines of code using the Amplify clients on my front end. Predictions leverage pipeline resolvers on AppSync. AppSync executes resolvers on a GraphQL field, as discussed previously. In some cases, applications require executing multiple operations to resolve a single GraphQL field. With pipeline resolvers, developers can compose operations, orchestrate, and execute them in sequence. In this example, the pipeline resolver is calling recognition to identify the text in an image. Then it saves it to what's called a stash. The data in the stash persists throughout the pipeline. The text from the stash then is passed to the second function in the pipeline that calls translate to translate the text, then calls poly to perform text-to-speech, all in a single GraphQL API call interacting with 3 different AWS services, saving network bandwidth and resources. Now let's move on to the last AppSync use case we'll discuss in this session. Very useful to power modern applications, seamless offline and data synchronization support. You can synchronize data between mobile web apps in the cloud using GraphQL when you're offline, leveraging AppSync built-in support for data versioning and advanced conflict detection and resolution strategies. The Amplify DataStore is a queryable local on-device data store for web, IoT, and mobile developers using iOS, Android, and React Native, running on-device or in browsers. Amplify DataStore provides a programming model for leveraging shared and distributed data without writing additional code for offline and online scenarios, which makes working with distributed cross-user data as simple as working with local-only data, allowing to create rich app experiences. Using Amplify DataStore, developers can build highly interactive, collaborative apps that support a wider range of offline use cases, providing more flexible access to local data. To power these capabilities, AppSync provides built-in support for advanced conflict detection and resolution strategies. When combined with Amplify DataStore, developers have a simple programming model where they can easily reason about consistency and data integrity, and can interact with data seamlessly whether you're online or offline. The data store provides a persistent on-device storage repository for you to write, read, and observe changes to data locally in web or native mobile apps. It can be used standalone without any cloud capabilities. The magic happens when you enable the cloud capabilities in the data store with a single command. If a developer chooses to sync with the cloud, the Amplify CLI will use the GraphQL schema to automatically deploy an AppSync API backed by a DynamoDB table for each type and an additional table used for Delta Sync, which is a journal that tracks changes in the application. The data store provides a simple programming model that always interacts with local data, that is automatically synchronized to DynamoDB behind the scenes, with built-in conflict detection, resolution, versioning, and journaling powered by AppSync. Talking about familiar programming model, the data store doesn't require developers to know how to code GraphQL on the client side. It provides simple constructs that are then converted to GraphQL automatically behind the scenes. As you can see, I can interact with my data with a couple of lines of code. The Amplify DataStore leverages a special sync-enabled GraphQL resolver on AppSync that connects to 2 DynamoDB tables, a table where the data is stored and a Delta Sync table. You can think of the Delta Sync table as a journal that is kept up to date by the AppSync resolvers on every mutation. Items on the table are evicted periodically according to a defined TTL to prevent this table to accumulate stale data. This allows clients to fetch data efficiently as they switch from offline to online states. Soft deletes are another interesting feature that AppSync Delta Sync implementation with DynamoDB data sources offer, which means the deleted items are kept in the base table with a tombstone flag for a configurable amount of time. This gives developers the opportunity to implement an undelete feature to handle accidental deletions by removing the base table TTL attribute before the item is deleted permanently. When you have multiple clients sending concurrent transactions to the backend, there is always the possibility that clients attempt to change the same item at the same time. This is where conflict resolution comes in handy, and it is another AppSync feature developers get out of the box with the data store. With AppSync in the data store, you can define different conflict detection and resolution strategies. One of them is auto-merge. Imagine you have a DynamoDB table storing data about pets. Shaggy is a dog and a beloved mascot in the AppSync team. Now there are two clients with access to Shaggy's record, and they try to update different attributes at the exact same time. Normally, one of the requests would fail, even if they were both valid requests. However, with auto-merge, both requests are accepted and merged. This can be done thanks to the nature of GraphQL, where fields of a type are first-class citizens. Now let's take a look at a couple of demos. Enough of talking.
So here I have an empty Amplify project. There's no categories defined. I'm going to add a category, an API category. I'm going to select GraphQL and then just use the default options there. It creates some boilerplate schema for me for a to-do application. I'm going to edit that schema and just add the schema definition that I want, that I need for the app that I'm going to demo. We're going to use the Add Predictions category to showcase how we can integrate AI and ML to your application. So we're going to translate an image, translate the text in an image, convert text to speech, identify the labels with basically two simple API calls. It's a React application, has only 107 lines of code, very simple, and again it makes two API calls, right? Just a single line of code to connect to AppSync. So I'm gonna push, so Amplify deploys that to the cloud automatically by CloudFormation, generates CloudFormation templates and deploy all of them. Actually, I need to add storage to my project because I need to upload images, and those images, they need to be stored somewhere, and they are going to be stored in S3. So, of course, those S3 buckets need to be secure, so we also add Cognito to the mix, so we can define permissions for guest users, for private users, and things like that. So I want to enable guest users so they have access to upload images. And then that's it. So I have everything that I need. I just need to push my changes. Then it's going to create the CloudFormation template. It's going to deploy all the services that I need with permissions and everything connected. I'm not going to do that because as any good cooking show, I have the meal prepared here. I already have an application ready to go. I apologize, the fans on my laptop, they're going loud and crazy now. So here is the pipeline resolver that Amplify creates. So this, it calls recognition and then translate and then calls a Lambda function that issues a call to Poly. So it's all my data sources in AppSync here. I also am hosting this on the Amplify console, so I can host automatically my app in the cloud. And also, of course, built-in CI/CD, I can deploy changes, and all my categories are there. I can access that from a single pane of glass. Sorry. This is my app, right? Very simple app. You just upload pictures, and then it does whatever it needs to do with the AI services. I'm going to upload my picture here. And then let's see the result.
Ese momento cuando tu código funciona mejor momento.
The Spanish speakers out there can confirm, and also, that moment when your demo works, I gotta love that as well. So now let's try to check the labels. What recognition?
Person, Tai Chi, martial arts, sports, clothing, suit, coat, advertisement.
You can see here a single GraphQL call. We just issued that query. It called all those services automatically with a single API call. Okay, this is predictions. Now, how we can integrate AppSync with AI ML. Now let's move on to a second demo. So in here, we are now going to go ahead and showcase DataStore. So empty project again. I'm going to now add a category again to my project, an API, GraphQL API. This time I'm going to select Cognito, so I want a secure app where I can manage my users and authenticate and authorize users to access it. I'm going to add additional settings, and I'm going to add conflict detection and resolution. When I do that, basically Amplify is going to AppSync to set up the data store. So here again, I'm going to add my schema definition, right? By default, I have this to-do model, it's boilerplate. I'm going to add actually what I need with auth rows to allow just the owner to edit whatever it creates. And then just define another field here. That's it, and I'm ready to go. Now just push my changes, and again it's going to create all the resources, create CloudFormation templates, deploy everything automatically for me. It's as easy. I'm not going to do that again. I already have an app ready to go, a project deployed. Let's take a look at it. So this is the project, and I'm going just to start a local server. This time I'm going to test locally. This is my app, again a React app. And the development service to starting. And this is the code. It's about 180 lines of code, but can do a lot with 180 lines of code in DataStore. You can see it's very simple. Just issue those operations, save to save data, query. I can search and query my DataStore locally, delete, also clear DataStore if a user logs out, and observe allows to observe changes in the backend and use GraphQL subscriptions to do so. So it enables real time in the data store. There you go, my app is ready to go. I added Cognito and user signing. And this is what Amplify creates in the backend. Those extra fields there, they are defined for the data store. They are leveraged by the data store. And this is my data source, which is also created automatically with the add model directive. So I have a DynamoDB table. If I look at the settings of the DynamoDB table, so yeah, I have two tables, one for my DataSync table and the table with the data itself. As you can see, the table is empty here. Now I'm going to log in with my user. And also let's open the developer tools just to open the hood and see what's under the hood there. I can create a couple of course, nodes there. And if I go to the application section, you see here I have IndexedDB table here with all my data. It's all running locally. That's why the app's so fast. I'm always interacting with local data. And automatically behind the scenes, the data is sent to AppSync to DynamoDB. And here are my my data there. So the nodes I just created. So let's test real time now. What if I have two different clients? Imagine I'm on an iPad and I just want to create a node, and I'm here with the app open on my laptop. you see automatically pops up on the other clients using subscriptions and WebSockets, all managed by AppSync. And again, my new nodes right there. Now, what happens when you go offline? So let's simulate that. So now I'm fully offline, and I'm going to do some operations, right? I'm going to remove that last node I created. I'm going to create a new node. I'm going to add that. If I go to my DynamoDB table, I won't see anything because, of course, I'm offline. Let's go back online. And you can see a couple of network calls. And then my new nodes are there. My new offline nodes there. And you notice my node, the node I deleted is there too, but it has a flag deleted. It's not showing up in my front end, but it's there. I can undelete if I add that logic. But yeah, this is it. This is the Amplify DataStore powered by AppSync and DynamoDB, so providing that seamless integration between local data and the cloud.
So with AppSync, you can start effortlessly with your GraphQL journey on AWS. It scales with your business, and you just pay for what you use. Provides powerful built-in real-time and offline capabilities, allowing you to unify and secure access to multiple data sources, APIs, and services. Amplify provides fantastic development tooling and integrations with AppSync with the Amplify DataStore, GraphQL Transform, local mocking, and automatic code generation. If you're curious about the customers and the diagrams you saw in the previous slides, check this link. We have presentations and videos from each one of them explaining the architecture and how they're powering their applications with GraphQL and AWS AppSync at scale. AppSync helps your application get to new heights. Thank you very much. I hope this was useful. And I think we're gonna have some time for a Q&A.